Okay, so let's go ahead and continue talking about this. We'll go on this side first, then we'll go ahead and go on that side. It says here, brainstorm. What are some solutions, or sorry, some situations that involve projectile motion? So they're just asking for a few examples. We've already said a few examples in our other set of notes, but just a few examples of projectile motion would be kicking a soccer ball. How about that? What about launching a cannonball? What about jumping? Whether you're, for an example, you're going to do the high jump and like pole vault over, or whether you're going to do the long jump, or you're jumping to see how far out you can jump, throwing a football. Hitting a golf ball with a golf club. The moment you release that, the ball releases from the golf club and it's out. It's a projectile motion. Throwing a paper airplane, the projectile motion. Now, what about a real airplane? The moment it takes off from the ground. No. Why? Because there's an engine in that airplane. Okay, projectile free fall motions are going to be objects. Look at all those objects. They don't have any extra engine or energy inside of them to help them so they can continue to fly. Let's go ahead and go on this side. It says, in a snowball fight, two siblings are tossing snowballs at one another. If the sister launches a snowball at her brother, at what point does the snowball have A, no vertical velocity, and B, the same speed it had upon launch? Okay, well, let's go ahead and answer this. They're asking for part A and part B. So for part A, this would be at the location the snowball reaches its maximum height. At this point, the vertical velocity is 0. What happened here was that it was going up, it stopped, and that's what we're talking about, and then it changed directions and started to come back down. Part B says, at what point does a snowball have the same speed it had upon launch? So the speed is the same when the snowball is at the same height as the launch height. The moment that they are at the same height. So the moment it was released, wherever it was released at, it's going to go, and when it gets to that same height of where it was released, then it will